All right, everyone, welcome to lesson 23. In lesson 23, we're going to be talking about how we can solve problems with inequalities in two variables. Last lesson, we talked about how to graph inequalities in two variables, and in this time, we're going to focus on how to understand that in context. So, our learning goal for today is that we're going to practice writing, interpreting, and graphing solutions to inequalities in two variables. Here, there are going to be two situations given to you and the two questions about each situation. I want you to write an inequality to describe the constraints, specify what each variable represents. I want you to graph the inequality using things that we learned from our previous lesson. Sketch the solution region on the coordinate plane, and I want you to label the axes. You want to name one solution to the inequality and explain what it represents in that situation, and I want you to answer the question that I gave to you. So, in our first situation, a customer opens a checking account and a savings account at a bank. They will deposit a maximum of $600, some in the checking account and some in the savings account. They may not deposit all of it, and they might keep some for money as cash. If the customer deposits $200 in their checking account, what can you say about the amount deposited in their savings account? First thing you want to do is determine the information you know and you don't know. What information I know that the customer opens both a checking and a savings account. I know that they deposit at most $600, right? At most tells me that I'm going to be talking about something that is less than or equal to $600. Information I do not know. I don't know how much was deposited in the checking account, and I'm going to label that a variable C since I don't know what it is. And I don't know how much was deposited in the savings account, so I'm going to label it with a variable S. My first responsibility is to create an inequality. So I know that how much deposited in the checking account plus how much was deposited in the savings account must be at most $600, which is going to be less than or equal to $600. So my inequality is going to look something like this here. My second step is to graph my inequality. Your first step of graphing your inequality is to label your axes. So I'm going to label my axes by saying my checking account and my savings account. It should be the amount of in my checking account and the amount of in my savings account if you want to be more specific with your variables. The second step is to figure out your scale. I'm going to go by 100s here just because we are going up to 600. I thought that was probably the easiest way to label it. And so that would be 100, that would be 500. We know that is less than or equal to, so I'm talking about a solid line here. I know my intercepts are at 600, 0, and 0, 600. And so remember, if this is something you're struggling with, I suggest go back and watch lesson 21 and 22 video. So that means 600 would be here. So I'm going to create a solid line because we're talking about less than or equal to in that case. I'm going to test a point. I'm going to test a point 0, 0. This is step 2, right? I'm going to test a point 0, 0. And that's going to be, that tells me 0 plus 0 is equal to 0. 0 is less than 600. And so I'm going to shade underneath the line. So that is my the graph of my inequality here. The last step was my question given to you. Tell me one solution in your inequality. One solution in that inequality is in your shaded region. And so in that shaded region, I have the point 0, 100 to 100. And what it means in context is a customer deposits $100 into the checking account and $100 into the savings account, which is less than 600. Please give me a full sentence when you are telling me what the solution represents in context. The last part was asking about the question in context. And so the question was given, if the customer deposits $200 in their checking account, what can you say about the amount that was deposited in their savings account? And so fill out the sentence here, right? If the customer deposits $200 in their checking account, the deposit is less than or equal to how much money in their savings account, right? If they can have a max of $600, what is the deposit into the savings account must be less than or equal to how much money, right? I want you to fill in that last part there for me. The second situation that you're going to deal with, in this case, we have two mini situations with our concert tickets. We have two kinds of tickets to an outdoor concert were sold: lawn tickets and seat tickets. Fewer than 400 tickets in total were sold. If you know that exactly 100 lawn tickets were sold, what can you say about the number of seat tickets? And you're going to graph it here. So I want you to go through the same steps that I did in my previous example. If you need to go back and watch that part of the video, feel free to go back and watch that part of the video. The second example I want you to go over is lawn tickets cost $330 each and seat tickets cost $50 each. The organizers want to make at least $14,000 from ticket sales. And so in this situation, we have a little bit more information. And if you know that exactly 200 seat tickets were sold, what can you say about the number of lawn tickets? So in this situation, what do I know here? I know that lawn tickets cost $30 each. I know that seat tickets cost $50 each. And I want you to make at least $14,000. So that means for at least $14,000 is greater than or equal to $14,000. What we don't know is how many lawn tickets there are, and we don't know how many seat tickets there are. And so when you're creating your inequality, you have your cost per your lawn ticket multiplied by the number of lawn tickets you have, added to the cost per seat ticket multiplied the number of seat tickets you have, and that must be greater than or equal to whatever your total is. And so I'm giving you at least a benchmark. You're going to have some numbers here instead of just variables for this example as well, as you're creating your inequality here. And so in this lesson is really just going to be a little bit of extra practice going over everything that we've been talking about in our over the past few lessons. And so in the card sort, I want you to take a look at the cards. I want you to take a look at the you have you have inequalities on one column, you have graphs in the middle column, and you have a solution in the last column. So what you're going to do is you're going to take a look at your three situations. Take a look at your three situations, and I want you to tell me which inequality represents a situation, what is a solution to that situation, and I want you and give me which graph is the sketch. You don't have to resketch the graph out. You could just tell me if it's graph A, graph B, or graph C. So in this time, I gave you all the information. I want you to just match it to each of the situations here. And so in our overall, right, you can use technology to find the solution to a variable as an inequality. I want you to give it, when given the inequalities in graphs and descriptions that represent the constraints in a situation, I can connect the different representations and interpret them in terms of the situation. So in this lesson, we're not doing anything entirely new. We're just connecting every single piece that we've been talking about before we go into our last lesson in this unit. So this lesson is a little bit more practice understanding how we can put our variables in context and what we can do to understand our situation here of representing inequalities in a context. So I look forward to doing some more practice with you in class.